There are differences in the brains of people with dyslexia that we can measure with brain imaging, and it's believed that many of those differences already are present at birth, and other differences may be there because of them not having the same kind of reading experience as a person who doesn't have dyslexia. And we measure these differences primarily with magnetic resonance imaging, and the differences that we see are reflected in the different kinds of analysis we can do with MRI. So we have people inside the scanner do, say, a reading task or a sound deletion task, and we look at how does the activity in the brain differ. And that activity is measured locally in the brain, which areas differ, but also people use the data to look at the amount of correlation across those different areas. So it's a sort of a functional connectivity. And you can take any of these measures and try to incorporate them all together to get a really good understanding of how does the brain in people with dyslexia differ in terms of the anatomy, the function, and as a network, how all these areas fit together. And the areas that we're talking about are mainly areas involved in reading or in skills that we know that support reading. The finding that most people agree on is that when you look at the left hemisphere in studies of groups of people with dyslexia and people who do not have dyslexia, and I emphasize it's really group studies, is that there is differences in the anatomy, primarily in the left hemisphere, in regions that are known to observe language and written language, and that's also where we see differences in activity. So when those participants are doing a task that involves reading or something like manipulating phonemes, they may underactivate those parts of the brain. They're not using them quite to the same level, even though they were actually doing the tasks. They just aren't engaging those areas quite so much, particularly an area in the back of the brain, in the areas around the temporal and parietal cortex that are involved in helping us understand how sounds are made up of how words are made up of sounds and how we map sounds to print, but also an area at the bottom of the temporal lobe that's involved in visual word form recognition. This is an area that we use when we read and we recognize words by sight. It's an area that a skilled reader trains up. It's how we become automatic readers, and that's also one area that's not activated the same way in people who have dyslexia compared to those who do not.